So question 4 says use the transformations to graph the function, determine the domain, range, horizontal asymptote, and the y-intercept of the graph of the function. So that's how we have this function y equals 4 to the negative x minus 5. So one thing we should recognize is our parent function is just simply this y equals 4 to the x. But notice how there's this negative on the inside and there's this minus 5 on the outside. So they're going to actually make something happen to the graph. So if I use my exponential tool, since this is an exponential graph, notice how it even says exponential tool when you highlight it, hover over it. So exponential tool, click on that. Again, if I come over here, again, 0, 1 is where I usually click because that's where we start at with the parent function. I don't think it really matters where you click. I think it still puts it there. So notice that since there's a minus 5 on the outside, that's actually going to make the graph, well, actually have these compressions and stretches. So we don't have any coefficients in front of the 4, so there aren't any vertical stretches or horizontal stretches. There is a vertical shift, but it actually goes down 5, so I need to move that to negative 5 because there's a minus 5 on the outside. There was no horizontal shift because there's no movement on the inside. There's not a plus or a minus in number on the inside. But notice how there was a negative on the inside. A negative on the inside makes it reflect over the x-axis. No, it makes it reflect over the y-axis because remember, inside is a left and right concept. If you reflect over the y-axis, that's a left and right concept. So that graph should kind of flip over in that direction. So that's what I should be looking for as our graph. So if I go back to our assignment, notice how we have y equals 4 to the negative x minus 3. So it's going to be basically the same thing. We're still going to use this exponential tool. It's going to start out here at 0, 1, but what we want to do is we want to change these settings down here. There is going to be a vertical shift, but it's actually going to be down 3. So I need to make that move to a negative 3. So these settings should stay at 1. There's not a horizontal shift either, but there was a negative on the inside, which is going to actually make the graph reflect over the y-axis. So that should be marked. So this, when I do that, this graph, instead of sliding from here to here, it should now actually be high on the left side and come down here. But the catch is, before we actually graph it, it's actually been moved down 3. So the horizontal asymptote, which was at y equals 0, is going to be moved down to negative 3. The point that was at 0, 1 is going to be moved down 3. So that should be at 0, negative 2. That's going to be the new y-intercept. And this graph is reflected over the y-axis, so it should be kind of coming down like this, and then it's going to actually approach that asymptote going to the right. So if I want to double check myself at y equals, I can type in this 4 to the negative x, come down minus 3. If I graph that, that's how we get the same graph there. If I look at the table, you kind of see the new y-intercept is 0, negative 2. And as you go to the right, notice how it says y equals negative 3. Actually, it's not true, but it's so darn close that the calculator can't distinguish between those because it's actually not supposed to touch the boundary line. So this is kind of distorted a little bit because the calculator, when it rounds to negative 3 because of that. So that's how the y values don't go below negative 3. Notice how if you just go a little bit to the left, like I said, when you get to, say, negative 9, it's already at 262,141. And then we have to actually use syntactic notation because the numbers are so big that way as well. So that's kind of what the graph is doing off in that direction. It just goes really off the graph. So we have our graph drawn. Again, our domain for this function, again, there aren't any domain restrictions, so it's still going to be just negative infinity to infinity. But notice how the range, there was a boundary at negative 3. So notice that our graph is above 3, actually. I'm sorry, above a negative 3. So negative 3 is my boundary. and we can't include it. So we have a parenthesis there for an open boundary, and then it does go to infinity. The horizontal asymptote, as we said, as we were pointing out, 0, -2 is my new intercept. The boundary line was this y equals -3. And my graph again kind of did this number here. It's kind of a sketch. So that's how it should be approaching this boundary line, which is called a horizontal asymptote. So the equation would be y equals -3 would be the horizontal asymptote. And the y-intercept again would be this -2. So -2 would be the y-intercept since it moved from 0, 1 down to 0, -2. So they just want the y value there. So -2 would be your answer to that.